Next, let's talk about a relatively more complex node, the condition node. The condition node, as the name implies, is a conditional node. It makes a judgment based on the condition we give it. Let's first talk about its logic. We'll draw a node. The condition node itself, it has relatively more input attributes. It's divided into several parts. First is the first term. This is where we provide a value. Corresponding to that is the second term. This is the second value. And then next is the operation. This is its calculation method. But specifically in the condition node, it actually refers to the comparison method between this first term attribute and second term attribute. This is divided into several cases. For example, equal, greater than, less than, greater or equal, less or equal, or not equal. We can choose different options based on our needs to compare them. After that is color if true and color if false. Although looking at the name, it says color if true and color if false. We shouldn't be confused by this name. They are actually just numerical attributes. It just so happens that in this node, this numerical attribute is called color. For us, we are still just processing numbers. Both of these attributes are the same type as translate and rotate. They are both vector types. They are both attributes with 3 value fields. But what's different is, because it's called color by default, its attribute fields are color if true, RGB, and color if false, RGB. The logic is the same, just the names are different, but the function is identical. So what role do these two attributes play in this node? For this, we have to talk about its output attribute first. Its output attribute is called outColor, and similarly, it's an RGB attribute. Let's use a few simple examples to understand how the condition node works. For example, first term. Our first comparison value is 10, the second value is 3, and the comparison method we'll choose is equal. So here, we need to compare the first value and the second value. This will branch into 2 situations, true or false. For example, let's say if it's true, output 5. If it's false, output -2. The final result is what's sent to the outColor. So let's compare these two numbers, 10 and 3. Between 10 and 3, 10 and 3 are definitely not equal. So at this point, it goes into the false situation. So here is 2. This -2 value is then passed to outColor. So the final outColor value is -2. Now, if we change the first value to 3, we know 3 and 3 are equal. So now we go into the true situation. The corresponding value is 5. So outColor now becomes 5. Where are these true and false values? It's what we just mentioned. Color if true and color if false. Another thing to note, as we mentioned, all 3 of these are attributes with 3 fields. So it's really RGB, RGB, and outColor is also RGB. So it's not just one attribute. We can set 3 values for it. For example, 5, 2, 3, and here -2, -3, -5. And here it's also 3 values. It will be different depending on the situation. Of course, just like when we talk about the plus-minus average node and multiply-divide node, even though it has 3 value fields, we can still just operate on one of those fields. So let's go back to Maya and see this node. Same as before, I have a driver object and a driven object. Go to the node editor, add these 2 in. Then let's create a condition node. We'll use translate x as the first term. The second term, we can type it in manually or connect it to another attribute. That's up to you. Then let's connect the outColor R to the driven object's translate x. This way, let's look at its operation. The default is equal, and we'll see not equal, greater than, greater or equal, less than, less or equal. Let's just use the default equal. And here, let's say color if true outputs 10, and if false output 5. Before we look at the result, let's think about it. Comparing 1 and 0, 1 is definitely not equal to 0. So the value output to the driven object's translate x should come from color if false. So its final result should be 5. If I change the second value to 1, then 1 and 1 become equal. Correspondingly, the value translate x gets is 10. This is the operating logic of the condition node.